When we think of a laboratory, high-tech machinery and shiny test tubes probably come to mind. But the reality is that lab equipment is very expensive and doesn't get upgraded as often as the scientists working there might like. Copenhagen Nanosystems has solutions to upgrade existing lab equipment and digitize the workflow. Emil, with Copenhagen Nanosystems, you're helping to transform the laboratory industry and bring everything to the digital state of the art. What are some of the things you're doing to make that happen?
We thought, how can we do this slightly different? So normally when you introduce new technology into a laboratory, you would do so by acquiring a new kind of instrumentation. The capital cost of keeping that running, especially in third world countries, can be very difficult. And also there's the maintenance part, and you need to have the skilled personnel in order to operate it. So we thought was, what if we could come up with a way to do this as a consumable approach, and then take all the skills that you would need to use it and put it into a software platform and use sort of modern software tools as a way to make it easier and faster and better to actually operate and do your measurements.
But with cphnano, you've got a combination, right, of software and hardware elements. So how does that come together?
It comes together in the sense that when you buy a consumable from us, it comes with an ID, a traceable ID that goes all the way back to our manufacturing in Denmark. This ID is then put into the cloud, and this opens up the calibration data from the consumable, from our factory, and give access to that. And based on that, we are able to provide much better measurements than you would have if you as a laboratory would have to do the whole calibration side of things yourself.
One of the first instruments that you're helping to transform and bring into the digital world is the spectrophotometer, because there's over 1 million of them deployed globally. How does the platform for cphnano bring the spectrophotometer into the digital age?
Normally, when you have a spectrophotometer, you are measuring the intensity of light and how that is lost over the duration of the sample. So you put your light through the sample, and then you measure what is the intensity loss. And this is a method that was actually pioneered during Second World War. But by adding more information into the spectra, and we have a little trick around how we do that with state-of-the-art nanotechnology out of the Technical University of Denmark, we can actually put more data into the same spectrum. And by doing that, we can actually read out more information in parallel and actually create whole new applications for this instrumentation. And that's what we call next generation.
Now, you have a really strong background, and you could have had a whole career in academia.
Yes, I could. Yes.
Most widely published person under 30, I think,
yes.
was where you were
Denmark,
in Denmark. What made you excited about starting down this road instead of academia?
I had a really nice career going. And then, but the thing was, I could see the technology we were developing at that time, doing my PhD, that was using, you can say, state-of-the-art nanotechnology. But I could also see that the work we were doing at the university didn't go anywhere. It was fantastic.
In terms of commercial applications?
In terms of impact.
Okay.
For me, it's great that we did the papers. It's great we have these wonderful projects. But at the end of the day, what I care about is getting in and making a difference in the world. And it is, if you want to make a difference in the world, you need to have a cash flow.
No, there's no question that in order to really have an impact,
and that's mean you need to
build a business.
You need to build a business. You need to see how do we scale, right?
There's so many government touch points around the laboratory industry. What would you like to see as a forward-looking regulatory framework, whether Denmark specific or more globally? What needs to happen to really help bring all laboratories worldwide up to the state of the art?
What needs to happen, in my opinion, is there has to be a uniform data format that allows it to make it very easy to submit data.
With standards around
With
this.
standards supporting it. And if that would happen, it would also make it much, much easier